All right, today we're going to get right under our skin, literally, to explore the incredible architecture of the human skeleton. It's the framework that holds us all together. But trust me, it is so much more complex and honestly, way more fascinating than you might think. Welcome to DrMedSimple. Let's make anatomy easy. Our whole mission here is to do just that. So today, we're going to strip away all the complicated jargon and just take a look at the brilliant, intentional design of our bones. So let's kick things off with a pretty basic question. Have you ever actually stopped to wonder why the bone in your thigh looks completely different from, say, the bones in your skull? Well, the answer is actually really simple and kind of elegant. Form always follows function. Every single bone in your body is perfectly sculpted for the unique job it has to do. And that idea brings us right to our first big topic, the 5 fundamental shapes of bones. You can almost think of this as the master blueprint for your body's entire framework. Each shape tells its own story about its specific role in how we move, how we protect ourselves, and how we stay supported. So here they are. You've got long bones, short bones, flat bones, irregular bones, and then a special, lesser-known type called pneumatic bones. Now, over the next few slides, we're going to break down exactly what each of these does. Ready to dive in? First up, we have the long bones. Their main job? To act as levers for movement. Just think about your femur. That's your thigh bone. Every single time you walk, run, or jump, you're relying on these incredible levers to generate all that power and motion. So, from those long levers, let's move on to short bones. These guys are typically cube-shaped, kind of like the tiny, intricate bones you'd find in your wrists and ankles. Their whole purpose is to provide stability and support in areas that need to make lots of fine movements. They're like these little compact powerhouses of support. Next up are the flat bones. You can basically think of these as the body's natural armor. Your ribs, for instance, form this protective cage around your heart and lungs, and the bones of your skull do the exact same thing for your brain. They're literally our built-in shields. And now for the misfits of the skeleton, the irregular bones. As you can probably guess from the name, they just don't fit into any of the other neat categories. And that's because they have very specific, very complex jobs to do. The vertebrae in your spine are the perfect example. Each one is so intricately designed to protect your spinal cord while still letting you have incredible flexibility. And finally, we get to pneumatic bones, which are a really fascinating specialization. You'll find these mainly in the skull, and what's special about them is they contain air-filled cavities. So you might be asking, why would you want pockets of air in your bones? Well, it's a super clever bit of engineering. This design makes the skull a whole lot lighter without sacrificing any of its strength. Okay, so we've covered all the external shapes, but what are bones actually made of? For this next section, let's take a little journey inside to see the bone's really intricate inner structure. We're going to explore this in 3 steps. We'll start on the very outside with something called the periosteum. You can just think of it as the bone's skin. Then we'll go a little deeper to the dense and incredibly hard compact bone. And finally, we'll zoom way in to the microscopic level to see the fundamental building block of that compact bone, the osteon. And here it is, the osteon, the tiny star of the show. I want you to imagine millions of these little hollow pillars all bundled together. This cylindrical structure is exactly what gives compact bone its legendary hardness and its ability to withstand so much stress. So the big takeaway here is this: our bone's incredible strength really begins at this microscopic level. But our journey inside isn't over yet. Deep in the core of many of our bones, we find this bustling factory. This is the bone marrow, and it actually comes in 2 different types, red and yellow. So these 2 types of marrow have totally different jobs. The red marrow is the body's blood cell factory. It's constantly pumping out all the components we need to live. The yellow marrow, on the other hand, is an energy reserve, and it's mostly made of fat cells. But what's really amazing is that the body can actually convert yellow marrow back to red if it ever needs to seriously ramp up blood cell production. Pretty cool, right? For our last section, let's zoom all the way back out to the surface of the bone. We're going to revisit that outer skin we talked about earlier, the periosteum, because it plays a surprisingly vital role, especially when things go wrong. And this, right here, is its most critical function. The periosteum isn't just some protective wrapper, it's the engine of healing. It contains the special cells that get activated to regenerate bone tissue and mend a break. Seriously, without this vital layer, healing a fracture would be incredibly difficult, maybe even impossible. So, after all that, what's the big takeaway? Well, from their 5 distinct shapes to their microscopic osteons and those marrow factories working deep inside, our bones are not just a static scaffold. They are living, dynamic, and self healing structures that are constantly remodeling and supporting us every single second of our lives. And that pretty much wraps up our quick tour of the human skeleton. I really hope this has made this amazing piece of our anatomy a little bit simpler to understand. If you found this helpful, please subscribe to Dr. MedSimple and like the video. Thanks so much for watching.